I don't know if I should be freaked out by that or not. Like today, I saw a yellow Mustang up there. That's a red van. I don't know what that is.
That's up at B. Seems cool. Alright, so
It's weird. I barely ever remember it. Talking. Hey!
Sean, who's skating?
Shut up. I knew there wasn't any team. I saw the video come up.
Chase?
Wait, is that all the way back here in the corner?
Yeah, because I was confused. Thank you. Oh, that's pretty cool. Made a Rubik's Cube into a cup. Great.
Oh, you see this guy all looking at me.
You're talking. You're talking. Yeah. You make eye contact when
That's
people
smart.
are
I don't
talking.
have to use the scrappy one.
Oh, gosh.
You gotta get
Nice.
protection off.
That's smart.
I don't like those scrappy ones. I'm used to those. They spin better. Guys, I'll show you why.
I never got those. I never really used those.
Because they're trash, right?
No, I just never really liked these.
Same.
Aw, Mr. Cole gone today?
Oh.
Aw.
Yes?
Oh, yeah, I forgot.
Yeah, fishing.
I'm stupid. He told us that all week.
That's what they spin on.
Oh, gosh, he's scared.
What is that? Coach is very, 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 very sharp.
Gosh.
What is that?
How was it for your contract?
Yeah. They're spin on. Where is he? It's part of the protractor. From my compass protractor.
Hey, Jason, we know who this
Abby,
is.
how do you braid your hair, dude?
It's the Punisher.
Oh.
He's from the
Imagine-
Marvel's old comic book.
Yeah, how do you braid your hair, dude? I just want to try braiding it. I have long enough hair. Go like wrap. Just make it three. Looks like go like this. Go like this. Really? Yeah, I can't.
I have protractor. I mean GoPro. I called the GoPro a protractor. I'm an idiot.
Anybody else fit math
Homework.
or math on?
Wait, we had homework?
No, we didn't have homework.
Oh, okay.
Just math. Bothering you. Alright, just the trick to where. What are you doing?
No, I did not do that.
Everybody say not already. When you said I'm gonna bother you, what would I say? No, not already. Would you not do it?
I just want to keep bothering you now. Hannah! What are you doing? Sean!
What?
What are you doing? What are you both doing?
I'm
What are
acting
you
like a
doing?
villager for Minecraft.
You look like my mom. With that, she does that a lot. That's Abby's new name. My mom.
No. I'm not Abby. I'm not your mom.
Yeah, I know. I'm just gonna keep calling you Abby.
You look to annoy people.
Hannah.
don't you?
I'll keep calling you Abby.
And you just got suddenly quiet.
That guy decided to shut up. Hannah! Well, we're just going out there.
Oh, wow. That was good.
Alright. We're missing that.
Missing
Cole,
that.
I know Cole's gonna be on. Alright, we're just taking some notes today. That's pretty basic, pretty easy. Now remember, homework that's due. I didn't put it up on the board. It's those 6 problems from the graph where you had to find like the distance from like Chicago to Denver. If you need that list, it's on the website. You go to the GHB, high school hsmath.org, go to general math and find either it was yesterday's, Wednesdays, Tuesdays, Mondays. It's been on there every day, so you can figure out what towns you need to go to. You use your map, you use a ruler. That's due today, and then the 3 problems with the Tesla models. That's due today. What cities you can potentially hit. There is a big range. I mean, that first problem, you're leaving Detroit using Model X. What cities can you hit? I had like 5 different cities you could hit, like major cities. The Tesla Model 3 from Orlando, it was like 2 cities you were going to hit. And then the Tesla Model S from Reno, that you could hit like 4 or 5 cities with that one. So, this depends on what you found online for the range of those vehicles. Okay, so that is due. So at some point, you got to make sure you're getting that wrapped up, because I know you need to use rulers and calculators and stuff. Today, we're just going to take a few notes. We're going to be in the midsection of Chapter 3. We're about halfway through Chapter 3 now. We're on Section 3.3 today, which what we're doing today is we're actually mixing 3.3 and 3.4 together. That's kind of what we're doing here. The main purpose of these sections is mixed numbers. Spell numbers correctly. So mixed numbers and improper fractions. So that's what we're going to do. That's our main topic today. So number 1, what I want to do, I want to talk about what is a mixed number. So let's do that definition of what that object is. Okay, so some people, they're not comfortable with that term, mixed number. They don't understand what it is. We're going to talk about the actual definition of it, and we're going to talk about like what is it used for, the uses of it. Why would we have it? The second topic we're going to talk about, we're obviously going to do the definition of an improper. Improper fraction. And what would the uses be of that? Like where you guys would actually use it. So that's going to be our goal today. Once we're through that, then I'll give you some time. You need to wrap up the city chart or the Model X part. That's what I want to give you some time. You need to work on that because I want to make sure that gets done. All right. Questions, comments, concerns? Okay. Let's jump right in. Let's talk about a mixed number. Okay. So mixed number. Let's go through the definition of it. All right. Mixed number, by definition, is a combination of a whole number and a fraction. Now, there is a term for fraction, and I'm going to put that on the board right now. Combination of a whole number and a fraction, which we need to realize is called a rational number. That is a topic we have definitely talked about at the beginning of the year, like the different categories of numbers we're going to discuss. We've been dealing with whole numbers. That was the very first chapter of the year. Chapter 2, we talked about the different sets and categories of numbers. But in chapter 3, we talked about fractions, which fractions are actually called rationals. That's anything you can write as a fraction is called a rational number. So it's a combination. So here's an example of a mixed number. That's a mixed number. Now, how would you say that number out loud?
3.5.
That's how I'd say it. I know some people refer to that as 3 1/2. It's the same thing. It's whatever the number is, you just say the first number, then you say the fraction after it. It could be any fraction that you want. It could be goofy looking, It could be something like that, where how I pronounce that is 7 11/12. That's how I pronounce that. Okay, but now, most people are very comfortable with that. They understand, what a mixed number is, but really getting a sense for, why do we have them? What's the uses of a mixed number? That's where it actually gets important. Okay, so let's talk about the actual uses here. Let's go to 3.5 here. First, write it. what does this actually represent? Well, if we go back and we talk about, fractions, like this half idea, what's the graphical way we display half? Like, how do we draw it? What do you remember?
0.5.
Say it again?
0.5.
0.5, that's the decimal of it, right? But what about drawing? Like, what does the picture look like if you look at like a pie graph or the bar graph?
Circle with one side filled.
Yeah. If you do the pie, right? Like the pizza idea. There's two pieces of the pizza. There's like two halves of it, and you have one that's left over. Okay. So you ate half of it, right? So there's half the cookie left or pizza, right? But what the actual number in the front means is that you actually have 3 full pizzas as well. So there's half of this pizza, and there's 3 other pizzas that are totally left over. The entire pizzas are still here. There. 3 full pizzas and an extra half. Does that make sense? So technically, you started with 4. You were almost 4 full pizzas, but you had that extra one here, this 4th one, there was only half of it left. 1 out of 2 pieces. Does that make sense? Now, what about the 7 and 11 twelfths? What does that mean?
It means like 7 pizzas and 11 of it is shaded.
Yeah, on the 8th pizza, right? The 8th one. We're almost 8, right? Because we're at 7 and a little bit extra. On the 8th pizza, there was 11 out of 12 pieces still left. So 1 was missing. Does that make sense? So that's the idea. That's what a mixed number is. That's the actual purpose of what we use it for. So I know, like in baking, they would say, like, hey, you need 3.5 cups of flour. Okay, so you have 3 big cups, and you have a half of that cup for the next one. So it's almost 4 full cups. That's the idea, or this idea of pans. So that's the idea. That's where most people, like, they can wrap their head around, like, okay, that makes total sense. Like, what do you use it for? But now, how does that apply to the new topic? Our other topic we have is called an improper. So let's do that. Okay, so an improper fraction. We're going to go through the definition of this thing. Okay, so what an improper fraction is by definition. It is a ratio comparing two numbers using division where the numerator is larger than the denominator. Okay, so let's talk about that. What is a numerator on a ratio, on a fraction? Top number, right? Denominator is the bottom number, okay? So what we're doing is we're picking a ratio, a simple fraction, right? So let me give you an example here of an improper. Now, the stipulation here is the numerator is bigger than the denominator. That's improper. That's an improper fraction. Okay, makes sense? Okay, so that's the idea. So now, when most people look at that, it makes sense. When they call it improper, it doesn't make sense that you had 11 out of 5. Like if I'm thinking about drawing the pizza pan, it doesn't make any sense. You had 11 shaded out of 5 pieces on the pizza, it doesn't make sense anymore. Okay, because there was only 5. How can you shade 11 of them? Okay? But now, how would this be used for you guys? Like, where would you see this? This would be used for extra credit. If you got extra credit on the test. The test was out of 5 points, but you got extra credit, so you actually received 11 points on the test, not 5. Does that make sense? That's where that would be a use for you guys. Now, the big deal here about today is that you need to realize there is a relationship between this concept, this improper, and then that thing right there. There is a weird, quirky relationship between mixed numbers and improper. There's a way, there's this like tool that we can use, this conversion, that I can change this fraction into a mixed number, and I can change a mixed number into an improper. There's a way to do that. Okay, does that make sense? I'm going to show you like how to do it with a picture, because and I'm going to show you how to just do it the shortcut. Like there was this little formula that we use. Okay? Make sense?
I think I know these people going for it.
Okay, good. Most people do. So this is our topic today that I want to discuss. Okay, but did my example somewhat make sense to you? Like what we're doing here? Okay, so I'm pretty sure you've seen these a bunch before, but I like to at least walk through it before we start trying to use these. Because later on, especially when we start like adding, subtracting, multiplying, dividing fractions, this is a big deal. You're going to get a lot of these at some point, a lot of improper, a lot of mixed numbers, and you got to know kind of what they mean. So, but let's talk about the mixed number. Let's go over here and let's talk about how do I somehow convert this thing into an improper, and then vice versa. How do I take an improper and convert it back? So I'm going to show you two different ways of doing this. So, our goal today is to learn how to convert. And what we're going to do today on this conversions, we're going to go mixed number right now, mixed number into improper. That's what we're going to learn right now. Okay, so we're going to start with this example, 3 1/2. 3 1/2. All right, so two ways to do it. Visual. Let's do the visual picture here first. Okay, so I'm going to go to this picture that we just used a little bit ago. Okay, so this is how to do this visually, how to make this fraction into one of those with just a picture in front of you. Okay, so the first step. Does this make sense, the drawing? Like 3 full pizzas and I have a half of the other one out of 2 pieces. All right, so here's how you do it. This is how I convert this thing into an improper using a picture. Number 1, you make every picture have this amount of pieces, the bottom number. So what's the bottom number in this case? 2. So I make sure that every pizza that I have pictured here has 2 pieces on it, every single picture. So what I'm going to do is I'm going to draw a line here, draw a line here, a line here, and then I'll put a line on this one, which is already there, but I'll put it in there. So every pizza now has 2 pieces. Do you see that? Okay, there's 2 halves. Okay, what I want you to do is count how many parts, how many halves there are actually shaded. So, how many shaded halves of pizzas do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7, right? And then how many pieces were in each pizza? 2. There's 2. 7 shaded pieces, and every pizza has 2 halves, 2 pieces on it. This, what you're looking at, this is the improper. That's the correct answer. That is the improper fraction for my picture. Again, how that works is you make every pizza have this many pieces, and then what you do is you count how many total parts were shaded out of the 2. There's 7 shaded out of 2 pieces on each pizza. Okay, now that's how you do it visually. There is a shortcut, and I'm betting on you probably know because you said it. Okay, there is this weird way to do it without the picture. Okay, what do you remember?
Want me to just say how I do it?
Yeah.
3 times 2 plus 1.
Exactly. It's what we call the circle method. You make this weird little loopy circle, and it'll give you your improper fraction. Okay, I guarantee that your improper fraction will have the 2 on it, because that's the bottom number, correct? So that's how we're going to do it. But the trick was, and you actually said that right, you take the big number times the bottom. So I'm going to take the 3 times the bottom number, and then whatever that number is, you're going to add it to the top number, because that was already left over. So I'm taking 3 times the bottom and adding the top. So what's 3 times 2? 6, right? That's 3 times 2. And I'm going to add the top number, which is the 1. So 6 plus 1 is? 7. So 7 halves. Now, to explain why, because a lot of people, you see the formula, but why? Why did they do that? Because what you're doing is that you're trying to figure out, in these 3 pizzas, if each of them has 2 halves shaded, there's a total of 6 pieces there. That's why we multiplied diagonally. And then you had to add the extra one that was left over. That's why we add the top number. Okay, so that's how you do it without the picture. It's multiply to the bottom, add the top digit. But again, that's when we're taking a mixed number and converting it to one of these. Sometimes the picture is easy to look at, but the formula is actually faster. Okay, now let's do the, what was that other example that I had up here? I had, what, it was 7 and 11 twelfths? Let's do that one too. Let's practice that one. Do another one of these. Okay, so 7 and 11 twelfths. Okay, these numbers are going to be big, right? So let's do it by the formula first. So the formula says I need to take the big number times the bottom, and then add the top number to it. Now, what's going to be on the bottom of this fraction? What's going to be on the bottom of my improper? 12. How I know it? It's always whatever this number is. That will always be on the bottom. So that's, in this case, going to be 12. Now, how we do this, 7 times 12, that is, 7 times 12 is an 84 on a calculator. And then you're going to add 11 to it. So adding 11 to that is 95. There. That's your answer. That's the improper for 7 and 11 twelfths. Now you're probably wondering, it's really big. Yeah, because if you think about this, I had 7 pizzas. There's a lot of pizza there. I had 7 full pizzas, and every pizza had 12 pieces on it. That's why this number turned out to be so big. That with, visually, I had 7 pizzas completely shaded. 1, 2, 3, 4, 5, 6, 7, and then the 8th one had only 1 missing piece on it. So it was something like this. So when I started adding all of these pizzas together, doing the visual, there's 12, 24, 36, 48, 60, or 72, 84, and then I added the extra 11 on it. So that's why it added up to be 95 total pieces shaded, and then there was, it was out of 12. Okay, make sense? Now, why you'd ever do that? Like, this is going to, like, if you're serving these pizzas, this is knowing how many pieces you have. I have 95 pieces to serve there. Out of, every pizza was 12 pieces. Okay, questions, comments? Okay. Now, improper. How do we convert improper back to one of those? Okay. I'm going to show you my little trick, and then I'll show you the real math today. The real math we'll do after lunch. Okay, so here's how I do it. Okay, I know that I'm going to get a really big number here, and I'm going to have a fraction behind it, back there. And I know the fraction behind will have a 5 on the bottom. That's going to be my setup. So does everyone can you wrap your head around that? Okay, so there's going to be some big number, and there's going to be a fraction back, and the fraction will have a 5 on the bottom. All right, we'll go to lunch. We'll come back. We'll discuss. That's going to be our setup right now. All right, we'll finish up our notes here, then I'll give you some time if you need to work on that math problem, if you need to finish it up, wrap it up. So we'll start here in about...
Yeah, how do you like me to
Ooh,
plug?
look at that red number. Oh wait, that's a chili. We're finishing up notes, and then we're after the rest of the time to finish up the line.
Just give you a stink eye. Hey, stop that wrong with you.
What?
Okay, notes.
Notes, and then the rest of the time is finishing up assignment.
Oh,
Stop it, Alex. You just bet my paper.
Well, for you. Right, Sean.
hey, should we do anything about that the other day?
No?
What about Saturday? What about Saturday?
No?
Why not?
Kevin goes to my dad.
Yeah, for Sunday. No, you can get
I'll
on
be
Sunday.
back Sunday.
Why not Saturday? Why can't you get home earlier?
Because I'm spending the weekend.
That ain't the weekend.
Yeah, it kind of is.
Well, Sunday is part of the weekend.
I sure my sheet.
Well, I can't bug Hannah. She gave me screen time. Or like hit me.
No wonder people want to hit you. Jason is the only one who doesn't want to hit you right now.
Well, I want him on the
Yeah.
Okay, all right, so hey, let's take a seat. Let's finish up our notes here, what we were starting on on this idea of improper, so we can figure out how to do it. I'm going to show you two different strategies to do this. I'll show you my shortcut for how I think of this problem, and then we'll talk about how we can do it with the actual process for it. Okay, so let me get rid of this. All right, and the number we're doing 11 over 5. All right, now what I talked about before lunch was that what we're going to try to do is we're going to try to write it into this form. A number, a big number, and then some fraction with the 5 on the bottom. So that's kind of what we're going to do. That's what we talked about right before lunch. Now, my goal is to show you two different ways of doing this. Okay, two different strategies. My shortcut, then the actual process. So you have two ways in case you like it or not. Okay, so here's how I do it. Number one, you start with the 11, the top number, and the 5. And what I want you to do is I want you to subtract 5 off of it. Okay, so what's 11 minus 5?
6.
6, okay? And now, if that number is big enough, can we subtract another 5 off of it?
Yes.
Yes, what do you get?
1.
1, all right. Is that number big enough where I can subtract another 5?
No.
No. This will be your top number right here. You subtract whatever the bottom number is a bunch of times. I don't know how many times you'll subtract it. You just subtracted the bottom of the 5, or whatever the number's on the bottom, as many times as you can. Okay, until I don't want you to go negative. If it hits 0, fine, but I don't want to be negative numbers. So right now, I have to stop, so the 1 will go on the top. How many times did I successfully subtract 5?
2.
2, that's the big number. That's your answer. That's 2 full pizzas and 1 piece left on the third one. Okay? That's what you're doing here. Because what you're trying to do is you're actually trying to set up pizzas where there's 5 pieces on them. 5 pieces, right? And you're trying to see, you're trying to see how many pieces or pizzas you can have where there's going to be exactly 1, 2, 3, 4, 5. All right. You're trying to figure out how many pizzas you can have before there's a total of 11 pieces shaded. So there's 5. There's 10 and 11. So that's 11, and so it's 11 pieces, and there'd be one piece left over in that last one. Okay, that's the idea. So that there's a total of 5 pieces in each. Okay, that's the idea. Okay. All right. Questions with that concept? Total of 11 pieces shaded. Okay. All right. Now that's the shortcut. No matter what the numbers are, you always subtract that bottom number off, and you see how many times you can successfully do that. Now the real process for how you do improper. Okay. And I'm going to show it with this number. You take the top number and you put it in the house, like for long division. So the 11 was the top number. You put the bottom number, the divisor on the outside. So the dividend is the 11. The divisor is the 5. So that's where I'm getting the 11 and 5 from. How many times can 5 multiply into 11?
1 time.
2 times. Twice. What's 5 times 2? 10. And then you subtract. That's a 1, right? 11 minus 10 is 1. That's your remainder. That's usually the R that we always say, the R of 1. Well, how you make this an improper fraction, a mixed number, is you take whatever you have left over, the remainder, when you do long division. So in this case, it's the 1, right? You put that on top of a fraction, whatever the remainder is, so if that was a 3 or a 4, whatever it is, you put it up here, and the divisor number, the number you were dividing by, goes on the bottom. That's the correct way to actually get mixed numbers. That's actually how they first evolved them. Whatever the remainder is, that will go on top of that number. Whatever you're talking about.
Did you do that on a calculator?
Yes, technically you could. The problem is certain calculators will not give you a mixed number out. They'll give you the decimals on the screen. So, but it is possible. Certain calculators. Okay, now here's my question to you. Do you want to see another one of those just to make sure that you know how to do it? Okay, let's do another one. Now let's make up our own numbers. So you don't need to be big. They can be any number that you want. But I want to an improper, and we're going to change it back to a mixed number. We'll do it both ways. So give me any fraction you want. Bigger number on the top.
800.
Oh, let's go small. I don't want too big. Okay, 80. All right, fine. That's smaller. Okay. What's the bottom number going to be?
12.
12? Okay. That's fine. So 80 out of 12. Do we agree that's improper? The top number is too big versus the bottom number. All right, so now by doing it by my shortcut, the shortcut I showed you a little bit ago, I know that the goal is to get a number here, and then there's going to be a fraction behind it with a 12 on the bottom. Okay? That's what I know. That's how we're going to change it back to a mixed number. Now, my way of doing this, the shortcut, is you take the top number and you try to successfully subtract 12 off of it a bunch of times. So, 80 minus 12 is 68. Now, can I subtract another 12 off of that? Okay, so we'll keep going. So 68 minus 12, which is 56. Yeah, that's why I didn't want you to do the 800. And then you take 56, and we can subtract 12 off it again, which is 44, and we can take 44 and subtract 12 off it again, which is 32, and then we can take 32 and subtract 12 off of it again, which is 20, and then we can take 20 and subtract 12 off it again, and we get 8. Now, can I subtract 12 off it again? No. That number, since it's too small, I can't successfully subtract 12, that number is going to be here. That's the remaining fraction. Now, how many times did we successfully subtract 12? 1, 2, 3, 4, 5, 6. We subtracted 6 times. That's the big number. We subtracted 12 6 times in a row. That's the shortcut that we do. So, all right, now, how do we, like, if you're not that person that likes to subtract, maybe it's, that's tedious. Especially if you have a number like 800. Ooh, I would not want to do that. So then that's where we do this little shortcut, where we actually do the real math. We do long division. Okay? So let's do the long division here. So
You're talking about 800 for this one?
no, let's do the 80. So we can see that the answer does work out. Okay, so we're still doing the 80 over 12. All right, so what number goes in the house?
80.
The 80. The top number always goes in the house, the bottom number always goes in the outside. So 12 can go into 80, what is that, 6 times? 6 times 12 is 72. Okay, 6 times 12 is 72. When I subtract 80 minus 72, I get 8. Now, how I get 8 is you have to borrow, so that's 7, that's a 10, 10 minus 2 is 8. And so that's usually your remainder, right? You have a remainder of 8. But the trick is, what you do is you take the 8, you put it on top of the fraction, the remainder, whatever that is, and you put this number on the bottom. That's your mixed number. And that's exactly what we found. 8 was the top number, and there was this total is 6 times we can subtract 12. Okay, make sense now? The concept is behind it? All right. We're going to deal with this more on Monday, but the rest of today, because I have about 10, 12 minutes here, I want you to work on that problem with the map. Can you find, what towns you could travel to if you had a Tesla, or if you're trying to find this distance between cities. If you still need that problem, I posted it online, and if you need a map, I have maps over there and rulers. But you need to make sure that you get that turned in today. I need that work. Okay? So if you have that, the distance between cities, and you have that, what town your model Tesla can go, it needs to be turned in my basket today. But again, if all fails, go on my website on hsmath.org, pull up the problem so you know what cities you need to go to. But I need that work turned in the basket, please. I have not received it from anybody yet.
You got it for me. Maybe it's still. I think it's still.
Just for the cars, yeah, just for the cars. Yes, sir.
On your website, you go to lesson, you go to general math, and you like click the latest one for like what we're doing with the math.
Yeah.
It says the person who set up this computer on the computer has chosen to block this side right to the video.
Yeah, they watch the video. It's cool there.
Yeah.
Yeah, the videos are blocked unless you're at home.
Oh, okay.
So they block YouTube here. So if you're at home on a local Wi-Fi, they work.
Wait for me to block. Oh. Keep trying to call me.
So.
Yeah, when you, was it yesterday, or what day did you go to?
For what?
Or like on the website? No, I meant like what day? Tuesday, Wednesday?
Oh, yeah, I don't know. Has to, oh, Wednesday.
Oh, okay, okay. That Thursday, there's no video on here. This one, right? Really wanted to watch that.
Okay, you guys free to go. Remember, at some point, you got to get this this idea with the maps and the Teslas turned in, please. Make sure your name gets on it.
I don't think these doors.